I'm going to put on, to finish my definition, I'm going to put on 2 more words. That's it. Just 2 more words, okay? And I'm just going to use, as best as I can, the language we've already developed, right? Because we just established what adding and subtracting is, right? Yep. Okay, this is coming on to what Kaval was mentioning, okay? Multiplication, multiplying, I think the simplest way to understand it is it's repeated adding. That's all it is, isn't it? Come on, think about it, right? Example, okay. 3 times 5. What is 3 times 5? Of course, you can start to talk about factors. You can start to talk like an area or that kind of thing. But really what it means is, well, it's 3, and then you add 3 again, and then you do it again, and you do it 5 times. Right? So you are putting together, you're adding on 5 sets that are all the same size. 3, namely. Yes? Yeah, that's right. Well, if I'd written it like this, then it would, right? I know we tend to think of these as the same, but they represent different ideas, right? Like, you know, the fact that multiplication is commutative is not immediately apparent because not all operations are, right? So, anyway, okay. So therefore, you can probably see where I'm going to go for division. It's repeated subtraction. But it's a little different. It's a little different. Okay? Oh, sorry. It's an ATM machine. Okay, so it works a little bit different to this. Okay? For instance, if I said 15 divided by 5, what does that actually mean? Why? In what way is it repeated subtraction? What it means is, how many times can I subtract 5 before I have nothing left? Okay? And the answer is, well, I shouldn't say equals. I can do it 3 times. I can do once, twice, 3 times, right? And that's when I have nothing left in my set. Okay? So that's why 3 times, that's the answer. Okay, now you can see why I had to establish this, because that's going to be our gateway to think about what this means, right? Division by 0. Okay, so, example. Okay, let's consider what is 1 divided by 0. Alright? So if I take this basic definition, right? It's, well, how many times can I take away 0? And you're like, well, I can take away 1 0, I can take another. I still haven't got to my set which had nothing in it yet, right? So you notice, there's 3 here. How many here? Answer, infinite, right? Or infinity, okay? So you might think, okay, so does it seem fair to say this? Okay. Now, I'm gonna push further on this a little bit, right? Because one of the ways that mathematicians solve problems like this is we say, okay, you got a problem, here's one way to approach it. Let's approach it another way, okay? Because, you know, you guys actually know a lot more about division. You know that it's more than just repeated subtraction, okay? So for instance, let's consider these. Let's consider these numbers, okay? 1 over 1, 1 over 0.1, 1 over 0.01, right? And I can keep going, okay? So, there we go. No prizes. What's it equal to? 1. 1 divided by 0.1. It's 10. 1 divided by 0.01. Okay, alright, so you can see where this is going, right? So now this is a different kind of argument, but this, if it kept going, it seems reasonable to say, well, yeah? Now this is interesting. I've approached this same problem from 2 completely different angles, and I've got the same answer. Okay? So this seems promising. Right? But there's a problem. There's a big problem. Okay? The problem is, you know, this game, right? This game that I played here with 1 divided by something and then divided by other things and so on, I can play it with other numbers too, can't I? For instance, I could do it with 2. Right? 2 over 0.1, 2 over 0.01, and so on, right? Now, all of your numbers, right, they're going to be twice the size. You're going to get 2, and then 20, and then 200, but they're tending toward the same thing, right? They're tending toward infinity. So that means this is where this is going is 2 over 0, right? So apparently 1 over 0 is equal to infinity, and 2 over 0 is equal to infinity, right? It's like, well, if you have these two things divided by the same, they should be equal, right? Now, you see, the reason why it was so important to go establish this, right, is that you can see this is not just playing a game. We've broken not just rules we decided or invented, right, but something which we knew to be fundamentally wrong. Here's 1. I should put it in this hand, sorry. Here's 1. And here's 2. And they are not the same, right? They are 2 sets and they are of different sizes. So this is wrong. This is wrong. It can't be, okay? Which means that this can't be, which means that none of that is true, okay?
Therefore, it's undefined.
Now, okay, so then comes the question, well then, okay, we call it, right, undefined, but why do we call it that? Is it just because it's like, well, I don't know, okay? And I'll show you why. Let's come back to this, okay? Let's come back to this. Okay. Now, I approached it from this angle, and I was heading from, this bigger number, 1, to 0.1, 0.01, and I was getting towards 0. That's the way I did it, right? I approached it. Now, there's other ways to approach 0, You don't have to just come down from 1 towards 0. You could go, for instance, from -1 and go up towards 0. I can do that, can't I? 1 over this, 1 over this. I'm still approaching 0. I know I'm still going to get there. Minus 0.001 and so on. I should still get to 1 over 0. Okay, but what happens? Minus 1. Minus 10. Minus 100? Minus 1,000? Where's this going? This is not going to infinity. It's going to negative infinity. Okay, now, this is where we get to the crux of the issue. Okay? Undefined. Why do we call it undefined? I used to think, you get your calculator out and you punch it in and it's like math error because it's undefined. You look it up on Wikipedia. You're like, a mathematician's just lazy? They're like, oh, well, I don't know what it is. We'll just not define it. No. In fact, undefined, it's undefined because it's undefinable, right? There is no number you can pick that makes sense. Right? Because, you put it this, and some other guy will say, well, but I can make it equal this, in exactly the same way you did, right? So there's equal sort of bidders for the crown of what 1 over 0 is equal to. Yes?
Isn't it like, because if you graphed it as a hyperbola, then it would never, because it never touches 0.
Right.
Is that
Okay, so
undefinable?
this stuff here, right, you can do it visually, right? You've got this, right? This is what we started with. Started at 1 over 1, which is like here, right? And then we decrease the value of the denominator, 1 over x, right? So we were going this way, and off we go up to infinity. But you guys know what the other side of the graph looks like, right? That's the other side of 1 over x. And off it goes down to negative infinity, right? So it's like, where am I going? Well, the answer is, I can't be going anywhere, right?
Because it doesn't exist.
That's right. The technical way of saying this is the limit does not exist. Okay? So it's undefined because you can't define it. It's not just because we haven't worked out what it's equal to yet. It's because we tried to work it out and you just get completely random things. Okay? So that's why 1 over 0 is undefined, because it can't be defined.